Hello class, today we're going to go ahead and look at section 7.2, inverse relations and functions. An inverse relation, we've already looked at this, but go ahead and recall from chapter 2, a relation is a set of ordered pairs. Okay, so relation is a set of ordered pairs. Okay, we have an example here. We're given the relation. The ordered pair is 1, 2, 3, 4, 5, 6. Identify the following: the domain and the range. The domain, remember, is your x values. And so in this case, my domain would be 1, 3, and 5. Your range for this example is your y values. Okay, so my y values in this case are 2, 4, and 6. So that would be my range. An inverse relation is a set of ordered pairs found by reversing the x and the y values. So today we're going to spend time finding, the inverse. So given the same relation that we had before, let's find the inverse relation. Well, all it is we change our x and our y values. So that first ordered pair is 1, 2, so now it's 2, 1. That's the inverse relationship there. The next one's 3, 4, so the inverse is 4, 3. And lastly, we have 5, 6, so the inverse is 6, 5. So that is what an inverse is. Example 1, the ordered pairs of the relation 2, 1, 5, 1, and 2, negative 4 are the vertices of a right triangle. Okay, we want to find the inverse of this relation and then graph the two relations. Okay, so let's go ahead first of all and find the relationship. The inverse relation for this one would be, well, we have 2, 1, so now it's 1, 2. It's 5, 1 up above, so it's now 1, 5. And then we would have negative 4, 2. So I'm going to go ahead and I'm going to graph the original relationship, which is the ordered pair 2, 1, 5, 1, and 2, negative 4. So here is my original. Now I'm going to go ahead and graph my relation. 1, 2, 1, 5, and negative 4, 2. Okay, if you go ahead and look, they should look like they are the same shape, and they are the same shape. And one thing that you should know about an inverse relationship is it will always be symmetric across the line. Y is equal to x. Okay? It's always going to go across that line. So if you look at those two triangles, if I were to flip it across that line, it should be exactly the same. Okay? So there you go. There's our example. Now, inverse functions, we're going to get into functions. Okay? The inverse of function f of x is, see this f to the negative 1 of x? Really what that's saying is f inverse. The way we read this is f inverse. Okay? If f of a is equal to b, so if I plug in a and get out b, then the inverse function, if I plug in b, I'll get out a. That's that switching of those ordered pairs. Now I'm plugging in b and getting out a. Okay, so it's flipping. So it says, find the inverse function of f of x equals x plus 2. Okay, so what we need to do in order to find the inverse is we go ahead and switch f of x and x. So we just rewrite them, switching. And then you go ahead, then solve for f inverse of x. So we'll do this with our example here. Okay, so I'm going to put, wherever there's an f of x, I'm going to go ahead and put x. So it's really going to be x is equal to, and then wherever there's an x, I put f inverse of x plus 2. And now I solve for f inverse of x. Well, the way I would do that is subtract 2. So I would have x minus 2 is equal to f inverse of x. So my answer is just x minus 2. There is my inverse. So now I want to go ahead and evaluate f of 5, Okay, if I evaluate f of 5, well, notice there's no inverse on it, so I'm going to go ahead and plug it into the original equation they gave me. So f of 5 is equal to 5 plus 2, which is 7. Okay. Now, the next one says evaluate f inverse of 7. Well, let's just think about what we got here. We got, when I plugged in 5, I got out 7. Guess what I'm going to get when I plug in 7 to my inverse? I should get out 5. Let's go ahead and double check. F inverse of 7 will be 7 minus 2, which is 5. Okay, so one thing to note, and this is the ordered pair, 7, 5. All right, so now we're going to go ahead and find a few more inverses. Find the inverse of f of x is equal to x plus 6 divided by 2. So same thing as before. I switch. Wherever there was an f of x, I write x. And wherever there's an x, I'm going to write f inverse of x. And I want to solve for f inverse of x. So I'd multiply both sides by 2. So I have 2x is equal to f inverse of x plus 6. I would subtract 6 from both sides. So I have 2x minus 6 is equal to f inverse of x. So that would be my inverse for example 2. Example 3. Go ahead and look at example 3. I go ahead and write, where there's an f of x, I write an x. And where there's x, I'm going to write f inverse of x. And I solve for f inverse of x. So in order to get f inverse of x by itself, I first need to subtract 10. So I would have x minus 10 is equal to 5 f inverse of x. Then in order to get f inverse by itself, I would divide by 5 on both sides. So f inverse of x is equal to x minus 10 divided by 5. There's my inverse for example 3. Okay. If you would like to go ahead and take a break, now would be a good time. You can pause the video and take a break. Otherwise, you can continue on. If you have questions, write them down. Make sure you ask me when you see me in class. Okay, the next thing we need to do is determine whether f of x equals 3 fourths x minus 6 and g of x equals 4/3 x plus 8 if they are inverse functions. Okay, the way you figure out if they're inverse functions, if you have to do composition, you take f of g of x. And if they're inverses, you'll get x here. And you have to do it the other way. You have to take g of f of x. And if that equals x, if both of them equal x, then they're inverses. You must check both. Okay? Can't check one. So go ahead, I'm going to start with f of g of x. So I'm going to take g of x, and wherever there's an x in f of x, I'm going to plug it in here. So I would have 3 over 4 times 3 over 4x plus 8 minus 6. And I start simplifying. 3 over 4 times 4 over 3 gives me 1x. 3 over 4 times 8. Well, 8 divided by 4 is 2. 2 times 3 is 6, so plus 6. And then I have my minus 6 at the end. This equals x. So far we're looking good. Now we got to go ahead and do the other one. Okay, now this time I'm going to go ahead and I'm going to do g of f of x. So wherever there's a, I'm going to take what my f of x function is, wherever there's an x and g of x, I plug that in. So I would have 4/3 3 over 4 x minus 6 plus 8. Go ahead and distribute. 4 over 3 times 3 over 4 gives me 1x. 4 over 3 times negative 6, well, 6 divided by 3 is 2. 2 times 4 is 8. Those cancel, so I'm left with x, so that works out again. So are they inverses? Yes, they are. But make sure you check both. Good. All right. Example 5. Let's go ahead and let's find the inverse. This time we're not going to go ahead and switch the variables because it's talking about the area is equal to pi r squared. Okay, so what we're going to do is we're just going to go ahead and solve for r. So area is pi r squared. I would divide by pi. Okay, now I would go ahead, I would have area over pi is equal to r squared. Now in order to get r by itself, I would take the square root on both sides. Remember, when you take the square root, there's two answers, plus or minus. But we need to think about, well, what is this? This is really saying my radius is equal to, can you ever have a negative radius? No, you cannot. So we only need the positive value. So it's a over pi. So here is the inverse. Okay. So what does the inverse function tell you? Well, it tells me what the radius is. Okay. So if I know the area, I can plug in the area and get the radius. Okay. The equation above, if I know the radius, I can plug it in and get the area. So it saves me a little bit of time for solving. Okay. The next problem says, find the radius of a circle with an area of 314 centimeters squared. Well, I would think area. Okay, so I know my area and I want to find out my radius, so I'm going to use the inverse function that I just found. Okay, so my inverse function is r is equal to square root of a over pi, and I would just go ahead and plug in what I know. I know that my area is 314 over pi. So on your calculator, you type in the square root of 314 divided by pi, and you would get that it's approximately 9.997 centimeters. Okay, that's a lot quicker than if you were to plug it into the other equation. If you would have started out with the area equals pi r squared, you would have had to go through and do the solving to solve for r. So the inverse will come in handy. Okay, let's look at example 6. Okay, the formula used to convert degrees Celsius to Fahrenheit is f of x equals 9/5 x plus 32. We need to find the inverse. Okay, so I'm going to go ahead and do that. I'm going to switch x. And in this case, they didn't label it with f and c, so I'm just going to go ahead and I'm going to make this x. This is 9/5 f inverse of x plus 32. So the first thing I do is subtract 32 from both sides. So x minus 32 is equal to 9/5 f inverse of x. Now we'll go ahead and multiply both sides to get rid of this by 5 over 9. And notice on the left-hand side, everything is being multiplied by 5 over 9. This part here simplifies to 1. So my f inverse of x is equal to 5 over 9 x minus 3 over 2. And you could distribute that if you wanted to. It's not necessary. Okay, so there is my inverse. Now it says, what can f inverse be used for? Okay, well, my original function was to convert degrees Celsius to Fahrenheit. So now this one is going to convert, we just switch them around. We're going to convert degrees Fahrenheit to degrees Celsius. Okay, so it all depends on which one you would use. Okay, so a nice way also just to keep in mind that you could have labeled this is you could have used F here and C for Celsius. Okay, and then here I would have had C and this would be F. So sometimes labeling with your variables is very helpful. Something to keep in mind. Don't have to do it, but it will help in the long run, I think. Okay, so this is it for the video today. If you have any questions, once again, please be sure to write them down so that you can ask me in class. Otherwise, have a great day.